This is David WA9ONY. This is a tutorial on GNU Radio number 2. First of all, we're going to use RTL underscore test. This is from the RTL underscore SDR, and it's going to test the sample rate of 1024,000. Hit enter. After select that. So here we get the sample rate, 1024,000, and we also get the gain values, 29 gain values going from 0 to 49.6. We're going to use that in the lab. To exit this, we're going to do a Control C. Notice that we lost some data. I find that that's common here when we first start up, that we lose some data at the initial startup. We'll go ahead and close this. We'll go back to GNU Radio. To control the SDR, we need the block OSMOCOM. We'll also need the block to show some data, and we'll go ahead and pick the Qt GUI sync. We can connect the two by first clicking on the output and then connecting the input. Now we have to set up the sample rate correctly, so I double click on the variable, change this to 1024. Say OK. Now we should have a working program. We don't see any errors up here. So we're going to go ahead and click on generate, and it's going to ask me to save something, save the file. So we'll go and pick GNU Radio command directory. We'll call this lab 2, and I already got a lab 2, so we'll call it lab 2B. Save it. Now we can go ahead and click on the arrow. The arrow runs our GNU program. Let's see the activity down here, and as it's finding the hardware and connecting to it. Alright, so this is the spectrum at 100 megahertz, which is in the middle of the FM band. So we'll go ahead and close this. And the easiest way is use this, they'll stop everything. Now, in lab 1, we notice that I changed this to 103.3. That's where KKCW station is. Well, we're going to change that by going and getting a GUI widget, and we're going to pick a range, and we're going to drop that right up there. Double click on it. So default, well, let's get the start first. So 88.1 e to the 6th. That's 88.1 megahertz. We'll stop at 107.9 e to the 6th. Whoop, I hit enter. Notice that this is in red. That tells me that it's got something wrong with it. Okay, so let's now the step size. The step size is 200 kilohertz. So I could put that in as 0.2 e to the 6th. Okay, the default. Let's pick my favorite station because it's a very powerful station, not because of the music or the programming. 103.3 e to the 6th. Okay. So we've got that. We're going to go ahead and hit OK. Now, it's not connected up to anything, so I like to do incremental try things. So I'm going to run this. In other words, generate the flow first, and then I hit the arrow. Arrow is going to bring up and start our flow graph execution. And we've got here our frequency. So if we go and take it down, there's 88.1, and move it all the way up, there's 107.9, and then there's, if we go ahead and click on these, it'll increment by 200 kilohertz. Okay, this is kind of a weird name. It used the variable name. This is not connected at all on anything up to the hardware, just the user interface. We're testing things out. Okay, so let's go ahead, and again, the best way to stop is go ahead and use this. It cleanly stops the program and cleans things up. So let's go back to this and use the label. So let's put in FREQ, frequency, period. And the next thing we're going to do is we're going to swipe this ID, and we're going to, let's see if, there we go. We're back again. Swipe the ID, right click on it, copy it. Okay. Recover from accidentally deleting that. Now we're going to go into this, and where we have frequency 100 megahertz, we're going to swipe that, and we're going to right click, and we're going to paste. Now that variable name is there. We go ahead and hit OK, and now the actions of this control are going to come down here. Now notice that it's 103.3. That's because the default value of this up here is automatically put in there. I don't see the variable name. I see the default value at the start time. So let's go ahead and generate the flow chart. We're going ahead and execute and run the flow chart. Wow, there's our strong signal. 103. Now let's kind of move this up a bit. There we go. We got the frequency scale now. Now the sample rate at 1024 000 or 1 point something megahertz means that the total span from the left edge to right edge is 1024,000, or 1 megahertz plus a little bit. So that's the sample rate determines that. If the sample rate was twice this much, let's say 2 meg, it would be 2 megahertz span for across there. Okay, the other thing that we discovered when we were messing around in Lab 1 is that depending upon the gain value, we occasionally got the signal and it would clip. So right now there's no clipping. In other words, this is at 1. I got a little headroom. Here's a -1. Here's a 1 here, and here's a 1 here. So actually the gain for this is quite nice, which is quite accidental. Probably yours is going to be quite a bit different. And again, we can review. We can look at the waterfall diagram, and we can click on auto if you'd like to see a slightly different type of scale. And there's 3 stations here. There's the center station at 103.3. There's no station here because we're still in the sidebands of this 103.3 or KKCW. But here, down here at minus 400 kilohertz is an FM station, and then plus 400 kilohertz is another FM station. So we are now got frequency control up here. Oh, I still got this. It says it doesn't look like I changed that, so that's a bug. Okay, so let's go ahead and I double clicked, not meaning to do that. Let's go ahead and stop that. Let's go ahead and double click on this. See, my label didn't get in. FREQ. Oops. Now we'll go ahead and do that. Okay, now let's put another QT GUI range up here. So frequency is number one when you're setting up your receiver. The second thing is going to be the gain is critical. So we'll go ahead and double click on this. We'll start at 0. And remember we went to 49 point something. Well, let's just say 50. And we'll go with steps of 1. And default, we saw that 10 was really a good number for at least my station. And then we're going to put in RF gain, GAIN. And here's our variable name, ID. We right click on it and we copy it. Okay, so we say OK. We double click on our other diagram here for the hardware. And we go ahead and scroll down. And we're going to change this by highlighting it. Right click and paste that variable name. So the first one ends in 0. That's going to be the frequency. The other one ending in 1 is going to be the gain value. And we say OK. Let's go ahead and generate the flow. After we're done generating flow, we can go ahead and execute our flow diagram. So again, GNU Radio generates a Python environment. And that Python environment is generated from my graphical choices here. And then in that Python, it controls C++ routines. Okay, so let's go to, we notice that looking at the time, in other words, as the horizontal axis, and the amplitude of the two IQ numbers, in this case, in phase, in other words, and quadrature. The in phase is the real, quadrature is the imaginary. Let's go ahead and start increasing it. Now we grab the slider and let's just crank it up. Whoa, look at that. We're heavily clipping. In other words, it's going up to 1 and it's going minus 1. And if we were to go and look at our constellation, whoa, look at that. It's at, it stays at 1 and goes to the minus 1, and then it goes again to the 1 here. So literally we have lost lots of data. Heavy distortion. Let's look at the frequency spectrum. Wow, hardly recognizable that the signal is there. So let's go back here. So let's go ahead and drop the gain. Yeah, click, 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 click. Now we want to back it off from, let's try 11. Let's see what 11 looks like. Oh, still clipping. See, let's go ahead and we can go ahead and click just one down there. There, 10. Just so happens, magic number here. Now let's continue going down. I am decreasing the gain, and notice that my signal is getting weaker and weaker. As it gets weaker, that means it's being dominated by the noise. So right here we can see we're half the amplitude of the perfect +1 to -1. Let's go take a look and see. Oh, notice that doesn't look as sharp. That's because there's more noise. So let's go back and put this back at 10. And it's slightly noticeable, and also notice that the fainter signal's kind of pulled up. And we got a little bit of headroom here. And we got headroom here. Okay, now that we've got two controls, you can have fun hunting around in the FM band. Let's go down, I don't know. .7, and I picked that because I was looking at finding a signal that generated a very nice round in-phase quadrature signal. So also this axis is a little bit distorted. We need to make the vertical axis bigger. And let's see. Yeah, okay, I'm going to grab that, pull it off the video. Keep going. There, we almost got a circle. Okay, next thing. Notice that we can increase the gain of the signal quite a bit. And in fact, if we go take a look at it, here's our real and imaginary. Again, it's just a different word for in-phase quadrature, or IQ for short. So let's go ahead and start cranking up the gain on this signal. Looking better, looking better. Might be clipping. Let's go check. Well, if it is clipping, it's hard to tell. Maybe we back it off to just 1. Now notice that this is a much cleaner circle. And the reason why it's cleaner, if we go back to the frequency, is that the signals around it are much weaker. Again, this is a dB scale, so this is bouncing around here. And -14, wow, we've got that real high. That's good. And we go down, 20 dB is a factor of 100. Another 20 dB is another factor of 100. So 100 times 100 is 10,000. So this signal is 10,000 stronger than any of the other signals, the other two signals here. In fact, there's a signal down here at the minus 200 kilohertz. So we've got one signal here, 2, 3 in the center. We don't have anything here. We have four signals here. Okay, let's summarize. We've added two controls. One control to change the frequency and step up 200 kilohertz from the bottom of the FM band at 88.1 to 107.9. The other thing we've added is a gain control. The gain control, we've chosen to go from 0 to 50 based on RTL _test, and we went in steps of 1. Those two controls now show up on our diagram, and we can change that in real time and see different frequencies in FM, and also change the gain to optimize receiving that signal. This is David, WA9ONY, 73 in QRT.